Hi friends, welcome back to our YouTube channel. We will see in this video few good questions, best question from power plant engineering, which is there for your syllabus for all the branches, civil, mechanical and electrical and other things also, right? Okay. Right, for your TS Telangana State AE GENCO. What is a power plant? Let us see the answer. So a power plant is an industrial facility that uses primary energy to generate electricity to supply power to the electrical grid for society's electrical needs. Most power plants use one or more generators that convert mechanical energy to electric energy. So basically a power plant is going to generate mechanical power that will be converted to electrical power with the help of coupling of the turbine shaft with the electrical generator shaft. That is the purpose of a power plant or power plant. That is the correct answer. Industrial facility that uses primary energy. So primary energy can be hydro energy or nuclear energy or even thermal energy also. Which of the following is the type of power plant? All the three are the types of thermal power plants. Thermal power plant, nuclear power plant, hydro power plant. That is the correct answer. In the thermal power plant, heat energy is converted into electrical energy. In the nuclear power plant, heat energy is converted into electrical energy once again. But here, in the thermal power plant, coal is burnt, fuel is burnt. But in nuclear power plant, it is through the fission reaction that heat is developed. Okay, in the hydro power plant, your water head will be converted into kinetic energy or potential energy of the water head is converted into electrical energy. Before that, it will be converted into mechanical power in the turbine, hydro turbine. That is the correct answer. What is hydro power plant? It is going to convert potential energy from water currents. It is going to electrical energy from the moving water currents. That is the correct answer. Okay. So basically, it is going to produce electrical energy from the moving water current. That means the potential energy of the potential energy which is stored at some height. That's called head of water. So that will be converted into initially kinetic energy because the water will be falling through a very greater heights. So it will be converted into kinetic energy at the end of the what you call penstock, and at the end of which it is going to be directed towards the turbine wheel. Okay, so that we are going to generate the mechanical part in the turbines, hydro turbines. So there are two important hydro turbines are there. One is the Kaplan turbine, other one is the Francis turbine, other one is the Pelton wheel. Okay, so basically it is going to generate electrical energy from the moving water currents. That is the correct answer. Which of the following is the cheapest plant in operation and maintenance? So here definitely your hydro power plant is definitely it is the cheapest plant of operation and maintenance. But others need a lot of we are going to incur a lot of expenditure for the maintenance of other power plants, thermal power plant, nuclear power plant, and also hydro energy also. It's a clean energy also. But we are having pollutions in case of thermal power plant and nuclear power plant. So your hydro power plant has two benefits. One is it is the cheapest power plant, and also we are going to have what you call clean energy, clean electrical energy produced. Alright, that is the correct answer. C. Where was India's first nuclear power plant was installed? Okay, it is at Tarapur, Maharashtra. Tarapur, Maharashtra. Tarapur is there in Maharashtra. This is a direct question. It consisted of two reactors, each generating around 150 megawatts of electricity. Right. Which of the following kind of energy output is obtained from a steam power plant? So definitely it is going to be electricity. But before electricity is generated, it is going to be converted into in the turbine shaft power or mechanical power. Okay, through the expansion in a turbine. So it is going to your steam power plant is going to involve or use a Rankine power cycle. Okay, so in which we are going to use a boiler, turbine and condenser and also a pump. In the turbine, the steam generated in the boiler is going to expand from very high pressure to low pressure, so that you are going to have a very high speed shaft power. We are going to get the very high high speed shaft power. So this shaft of a turbine shaft is coupled with the generators, electrical generators, so that we are going to get the electricity as the final output. Which of the following are the components of a steam power plant? Just now we have talked about that, friends. Boiler, turbine, condenser. In the boiler, steam is generated. In the turbine, steam is going to expand from high pressure to low pressure. In the condenser, very hot steam is going to get converted into hot water through the cold water through the exchange of heat to a cold water running in the condenser. In the pump, this cold water will be supplied to the boiler from the pump. So we have got two work input process, two heat. Two work process, two process involving work transfer and two process involving heat transfer. Heat absorbed and heat rejected, and work input and work output. Work input will be from pump. Work output will be from our mechanical. Okay, mechanical output, power output will be from turbine. Okay, similarly, heat input to the surrounding heat input will be in the boiler through the for the circulating fluid, which is water, and heat rejected in the condenser. So the four important components are boiler, turbine, condenser, and pump. Which of the following is also known as coal used in power plant? It is going to be D. It is called steam coal. So because of this coal is used to generate steam, it is also called steam coal. Others are not correct. Steam coal is the correct answer. Alright. So the net change in internal energy in a steam power plant is zero, because we know that from the principle of law of conservation of energy, we know that energy is neither created nor be destroyed, and similarly mass cannot be created, mass cannot be destroyed. So total energy of the universe is constant. So definitely in a steam power plant or any power plant, basically in a steam power plant, there is going to be two types of energy transfers. One is the work and second one is the heat. So net work transfer is equal to net heat transfer. So that in the total cycle, net energy transfer is zero. Next, as the steam power plant is based on a cyclic process has a net change in internal energy is equal to zero. Next, which of the following contributes to the improvement of efficiency of Rankine cycle in a thermal plant? All these are going to improve the efficiency of a thermal power plant involving Rankine cycle. So Rankine cycle, we can draw it like this, friends. Basically, TS diagram is a very important diagram. So it will be something like this. This is boiler, this is turbine, this is your condenser, and this is your what you call pump. Okay, 1, 2, 3, 4. Boiler, turbine, condenser, and pump. Alright, this is a TS diagram. This is a very famous diagram for your steam power plant. So here, if you see, use of high pressure is going to generate the very high heat content steam, so that we are going to get more power in the turbine. Second one is the reheating. Reheating is done in two turbines. One is that means after the expansion in the high pressure turbine, let us say, okay, so low pressure turbine, it will be once again heated, so that it is again supplied to the high pressure turbine. It is going to be expanding in the high pressure turbine. So there are basically two turbines. One is the LP turbine, other one is the HP turbine, low pressure turbine and high pressure turbine. So that we are going to have expansion twice, so that we are going to have mechanical power in two stages, LP turbine power and HP turbine power. So that we are going to have net work output is going to increase. After all, net work output is equal to work of turbine minus work of pump. Generally in the Rankine cycle, work of pump will be negligible compared to the turbine power. Okay, so reheating of steam in intermediate stage also is going to improve the efficiency and also regeneration. Actually, steam leaving after the turbine, in the turbine after the turbine expansion, it will be having lot of heat content, which can be utilized for a better purpose. So we are going to heat we are going to heat the water to be supplied to the boiler in an exchanger by heating it with the steam output from the turbine. Okay, so that your hot water will get your cold water will get heated, and so that your steam water supply to the boiler is at high temperature, so that we can add less heat compared to the normal process. So it is something called heat recovery process. So this is called regeneration. So regeneration, what is going to happen? Normally, the efficiency of a cycle is good work output by net work output by heat added. So heat added is going to be reduced because of the heat recovery. So that we are going to have a benefit of increasing the thermal efficiency of this particular steam power plant involving the Rankine cycle. So there are two things by which you can improve the efficiency of a Rankine cycle. One way is to reheating, other one is to regeneration. In the reheating, net work output will be increasing. In the regeneration process, here net heat added will be decreasing. All of them are the correct answers. Okay, friends. So in this video, we have seen some good questions from your power plant engineering for your TSAE GENCO, which is going to be conducted on December 17th. Okay, in the next video, we are going to see some more good questions from your examination point of view. See you all.